Hello, my fellow YouTubers. Yeehaw! NASCAR. Tonight I was in the mood to do some demonstrations for you guys, and this here is a good one. We are going to work on a demonstration using Hertzian waves. And this is a demonstration that Mr. Hertz had demonstrated propagation of electromagnetic waves, and he is one of the grandfathers of our delivery of waves. So let's take a look and see what I have set up here, and we'll go through there. All right, so this right here is my transmitter, and I have here a inductor. I have a Linden jar capacitor. This is salt water. The capacitance on this jar is about 1.22 nanofarads. This capacitor over here is tied up to my receiving coil. The receiving coil is set on a frequency to be similar to the inductor here, and it's running off this capacitor is similar, and the difference is this is about 1 point, I think it was 17 or 18, so they were really close. And what we have here is our transmitter. We have our receiver. We're going to talk about some antennas, some Yagi antennas, and how they're designed and built. Briefly, we'll do just a brief summary on them. This right here is just an extension of extending the electromagnetic wave that's being picked up, induced in the receiver here. And we'll go over this. I don't know how much time I have on my filming here, but we also have a frequency meter, and I got my spark gap. So basically I have my current, my power coming in, going to the spark gap, going to my capacitor, out of my capacitor into my inductor for my transmitter, and going over there to my receiver. Alrighty, let's go ahead and fire this up. Bam, I guess I'll kill that light. Hopefully you can still hear me. Got my spark gap. So right here we have our electromagnetic wave happen here on our transmitter. Our transmitter, the power, when it runs this way, the electromagnetic lines will run that way. And when the power runs this way, the electromagnetic lines will run this way. So right now we have electromagnetic lines running this way and being caught over here by my receiving coil. So right here you can see the light bulb lighting up. You can see that there's a good amount of power going through that inductor, that transmitter. As far as frequency, we'll talk about that when I get off. We should be shooting this over to AC. And we're going to hit function, megahertz, confirm, AC. We'll see that thing kick in. Also up here, lights on. Let's turn this light off here. These are cool experiments because it shows you the direction, and you can see that this area up here is lighting up. Man, the lights are bright back here. Great demonstration. I know I can't put you in the dark. I guess I do need light, but I don't need it shining on me. So we can go all the way out here, and with the electromagnetic induction that's happening over here with my transmitter, that's in a frequency in tuned to this right here, pretty tuned. So we're picking up the electromagnetic waves over here in what, 3 feet, 2.5, 3 feet. Also, you'll see that LED here I have hanging is burning my hand so much right now. You can see my finger having power being forced into my LED, which is amazing, guys. Okay, let's turn off the power. Sorry about the jostling of my phone. I don't know what else to do for videos, but so let's go over this. To get like the frequency that you want, say with your transmitter, you have your inductor, which would be that copper wire that goes around the length of it. You'll have your Linden jar or your capacitor, and the character of the frequency on that right there is determined by 1 over square root of the inductance times the capacitance. And then right there, that'll tell you what frequency you have that you're using. And basically, like on my receiving coil, you can walk around the coil and see what, but I knew that the length of this matched that frequency. So that's pretty interesting. And what you're causing in the field here is the alternating magnetic field. So what's happening is with the alternating magnetic field is creating an EMF in the loop, and it's just kind of going back and forth, and it's projecting all the way out to our receiver here. Another thing I'd like to talk to you guys about is antennas. Obviously, you can see we can build a transmitter, we can build a receiver. This ain't really an antenna. This is just a bunch of loops of crap that would allow me to extend the receiving's power that it's getting off this nice, electromagnetic field that it's picking up on. But what I'd like to talk about is some dipole antenna that I'm going to create and do a video next on a dipole. And a dipole antenna would be similar to my transmitter, how it's alternating its poles and reversing on each end here. And by doing so with my transmission line, we'll build a Yagi similar type of array that will be an antenna that'll have multiple nodes on it. And the multiple nodes will sort of take, if you go Edley Scallon style, and you take a coil and you wrap the coil up on some iron, you're creating a north and south pole there. So on these wrappings here on the PMH, you're going to see that the field becomes broader and wider, and then one side and the other becomes a pole. So by creating these nodes of these poles, you extend, and you pick, and it'll be a directional antenna that we're going to build on the video, and the direction will take a circle and it'll flatten it out so it's elongated. Then it'll be focused out, and you can focus the antenna wherever you want it to go. So it's cool stuff that's out there. Little ham radio knowledge. some old Tesla. By the way, this was inspired to me by, if you go to Tesla's archive videos, you'll see his big wall pancake coil, and on the side of it, there's this big square thing, and it's almost like a doorway, you know, in the pictures, and it's in several pictures where he has this big old flume tube lit up, like, well, flumes of electric coming out of it. And really, what it was his transmitter. The transmitter is the big square. The only thing I didn't do up top here is I didn't put a wooden piece across the top. But if you look at his pictures and analyze it like I have done for 4 years, finally it hit me that that square was the transmitter and his big pancake was the receiving coil. And it just teaches you a broad spectrum. And I'm putting this video out for the guys that are newcomers and beginners, how, you know, don't hurt yourself here. You know, you just want to learn that this right here makes a electromagnetic field that propagates out. And as it propagates out, it twists and turns and also has an electric field about itself, just like it does in space, where it's always like 90 degrees of the field